Video is going to introduce rational expressions. The notes can be found in topics. There's a rational expressions topic, and this video is going to go through pages 1 and 2 in the notes. So first of all, I'm going to ask you to stop the video and copy down the definitions that I have written here. And I'll read them and then I'll stop the video so that you have time to write everything down. The definition of a rational expression is simply a ratio of polynomials. And the object of this video is going to be to explain what's called excluded values or domain restrictions. And these are variable values that create division by zero, and division by zero results in an undefined expression. So as I said, I'm going to stop the video, let you copy these definitions down, and then carry on. Okay, so now you've got the definitions copied, and basically what we're going to do to get started with this topic, a ratio of polynomials, we're going to simplify our expressions. So they're not equations, they're just expressions, and I'm trying to get the camera to focus in for me, so give me a minute to let that happen. So what we're going to do to get started, you're going to look at the fraction, the ratio, you're going to factor the numerator and the denominator, you're going to list excluded values, and I'm going to show you how to do that, and then you're going to simplify. And you're going to do it in this order: factor, excluded values, and simplify. So let's get started on the very first example. So here's number 1. So the first thing I'm going to do is factor the numerator and the denominator. So I look at the numerator and I see that 8 is a GCF, so I'm going to reverse distribute out an 8. And remember that the fraction bar acts as its own grouping symbol. So when I have an expression, two terms connected by addition on either side of the fraction bar, I'm assuming that that's one number that cannot be split apart. So x plus 10 in parentheses must stay together. So as I said, factor is the first step. Then the second step is to list excluded values. Excluded values are variable values that create division by zero. Division occurs in the denominator of the fraction, so I'm only concerned with variable values that will create division by zero, or values that will make the denominator of the fraction 0. So if I set x plus 10 equal to 0, x equals negative 10. Therefore, this is my restricted value. So in order to state that properly, I have to state that x cannot equal negative 10. So this is my excluded value. X cannot equal negative 10. So I factor, I list my excluded values, and then I divide away the common factors. So in this particular expression, the binomial x plus 10 is common to both top and bottom. It's common to the numerator and the denominator. So the simplified value for number 1 is actually just 8. So let's just keep going with this, and let's just move on to number 2. So as the instructions state, your first job is to factor the numerator and the denominator. The numerator here is a difference of squares. So that's going to be x plus 5, x minus 5, factoring my numerator, and here's my denominator, x minus 5. And I'm going to go ahead and put parentheses around x minus 5 so that you know that that's a single number that stays intact. Now my next job is to list excluded values. I'm only concerned with values that make the denominator 0. So my excluded value here, if I were to set x minus 5 equal to 0, x would be positive 5. So that's going to be my domain restriction, or my excluded value. So I need to state x with the not equal to sign. X cannot equal positive 5. If x is positive 5, then this becomes an undefined expression, and that's something I don't want. I want to avoid that. So I factored, I've listed my excluded values. Now it's time to compare for common factors top to bottom. I see that the binomial x minus 5 is common to both top and bottom. So the simplified expression is just going to be x plus 5. The binomial x plus 5 is what remains when I perform all of my steps. Let's look at number 4 before we do number 3. So in number 4, I want you to notice that I've got x minus 5 in my numerator and 5 minus x in my denominator. They're almost the same, but they differ by a factor of -1. So the first thing I'm going to do is simply take my denominator and I'm going to determine which value is going to make this undefined. And if x is 5, this is an undefined expression. So my excluded value, I must state that x cannot equal positive 5. When I have a problem that looks like this, I'm going to recopy it down here. I've got x minus 5 and 5 minus x. If I were to reverse distribute a -1 out of that denominator, that's going to turn that into x minus 5. If I distribute that back through, I have -x and positive 5. So I'm doing this so that I can simplify the expression. So when you have the binomial factors that look like this, they're identical, but they're connected by subtraction, but the x and y have traded places. This is an expression that differs by a factor of -1. So here I'm going to divide out x minus 5, top to bottom. So this is going to simplify down as -1. That's going to be my simplified answer for an expression that looks like this. They differ by a factor of -1. I guess I thought I needed that skill for number 3. I really didn't, but we will need this skill later on, so I just went ahead and presented it. Let's look at number 3. And in my numerator, 16 and 64, 16 is common to both. If I reverse distribute out of 16, I'm left with x minus 4. And then my denominator is that difference of squares, x plus 4, x minus 4. So factor, list excluded values. X cannot equal positive or -4, and I'm only concerned with the denominator. Once I've factored and listed excluded values, I then look for common factors top to bottom that can divide out of the problem. They share the binomial x minus 4, so I'm going to divide that away, and then what remains is the expression 16 over x plus 4. And before I end the video, I'm going to talk about why 16 and 4 cannot divide out, but I'm going to carry on. I'll talk about that on the other page. Let's look at number 5. Notice in number 5, you don't have a variable in the denominator. So it doesn't matter if I have 0 in the numerator. 0 in the numerator is totally fine. That's okay. It's 0 in the denominator that's not okay. So if that helps you at all, please just try to internalize that and understand that. So here with number 5, there are no domain restrictions, meaning there aren't any restrictions on what the variable value can be. So there are no domain restrictions. There are no excluded values. And actually, this is an expression that can't be further simplified, and it falls into the same category as the problem above. The 3 and the 6 are off limits, and I will explain that before I end this video, before I close this out. Let's move to page number 2. And in page number 2, this is where I need to think about that factors that differ by -1. So let's look at problem number 6. My first job is to factor the numerator, factor both numerator and denominator. So here I'm going to have 6 plus x and 6 minus x, and then my denominator is x minus 6. So let's list our excluded values, looking at my denominator only. So my excluded value is positive 6. X cannot equal positive 6. And so when I'm analyzing this, I notice that I've got this opposite binomial thing happening here. So I'm going to rewrite this, and I'll let the numerator take the lead. If I were to reverse distribute a -1 out from the denominator, then that's going to turn that expression into 6 minus x. And now I compare for common binomial factors, dividing those out, and then what's going to remain is the -1 with the numerator of x plus 6. So the way that I would present that answer, probably you would most likely see it presented like this. The numerator written as x plus 6 in parentheses with a negative sign in front of it. You could also distribute the negative sign and say negative x minus 6. That would work as well. But I'm going to move on to number 7. So in number 7, looking at my numerator, let's see my numerator, they both share 5, leaving me with 4x minus 5. In my denominator, they both share 10, leaving me with 5 minus 4x. So listing my excluded values, x is not allowed to equal, let's see, I divide by, subtract 5, so x is not allowed to equal positive 5 over 4. I would subtract 5 and then divide by negative 4. So that's my excluded value. But the interesting feature about this problem is I've got the binomials here that are differing by that factor of negative 1. So I'm going to redo the problem. 4x minus 5 is my numerator, and I'm going to take a negative 10 out of the denominator, which allows me to take this binomial and flip it, and I can now divide out 4x minus 5, 4x minus 5, and my simplified expression is negative 1/2. I would then simplify 5 over 10 to get negative 1/2. Let's move on and get into the polynomials that require a little bit of factoring. So here, my numerator is going to be x plus 1, x plus 2, and my denominator is x plus 5 times x plus 2. I'm only concerned with restricted values, domain restrictions, excluded values in my denominator. So my two values that I would have to throw out would be negative 5 and negative 2. It's just division by 0 that creates the undefined expression. So I've factored, I've listed my excluded values, and I now see that I've got x plus 2, common binomials to both pieces, and my simplified answer would just be the two binomials that remain, and you could express your answer as x plus 1 over x plus 5. That would be the simplified expression for number 8. Let's look at number 9. So I have a difference of squares, x plus 9, x minus 9, and my denominator is the perfect square trinomial x minus 9 times x minus 9. So my domain restriction, x cannot equal positive 9. Remember, the domain restriction is only applied to the denominator. And then you've factored, you have listed your excluded values. You're now looking for common factors to divide out of the problem. And your simplified expression is going to be x plus 9 over x minus 9. And as I said, I'll explain why the 9s are off limits in this particular problem. And let's look at number 10. So here I'm going to have x minus 9 times x plus 5. And my denominator is going to be 5 plus x times 5 minus x. So my excluded values are positive and negative 5, going along with my denominator only. So I have factored, I've listed my excluded values, and it's now time to simplify. So I've got 5 plus x and x plus 5. They're actually exactly the same because addition commutes. So my simplified answer here would be x minus 9 over 5 minus x. Or you could possibly see this written as x minus 9 over negative x minus 5. You could possibly see it written like that. Both are the same, and it's important to be able to recognize both. Let's do number 11, and then I want to give you an easy way to remember why some of these things that you would like to eliminate, why something like why the 9s, why you cannot divide out the 9s. So let me do number 11, and then I'm going to get to that example. So number 11, I have a GCF in my numerator, and then my denominator is x minus 5, x plus 2. I list my domain restrictions. X is not allowed to equal positive 5 or negative 2. And then I look for common factors top to bottom, and they both share the binomial factor x minus 5, which I divide out of the problem. And then I have left 2 on top and x plus 2 in my denominator. Now let me try to give you a simple example to understand why the 2s are off limits, why the 9s are off limits. And this is the easiest example type that I can come up with. if I have the fraction 15 over 20, and 15 is 5 times 3, 20 is 5 times 4, the common 5s divide out of the problem, leaving me with 3 over 4. And everyone is that this is the correct answer. If I were to apply the logic above, if I wanted to take the 9s out, or if I wanted to divide the 2s out, this is what I would be doing. I could think of 15 over 20. Well, I could think of 20 as 15 plus 5. And then that would, with applying the incorrect logic, I would divide the 15s away, and I would be left with 1 over 5, which we know is not true. So this is a not equal moment. And for me, that's the easiest way for me to explain why the 9s have to remain and why the 2s have to remain. This is not just a 2. This is the number x plus 2. And this is the number x plus 9 over x minus 9. So the 9s are not candidates for dividing out of the problem. And this is the easiest way for me to explain that.